Hey guys, Andre from High Performance Academy here. Welcome to another one of our webinars. Now today we're going to be talking about something that's quite close to our heart right now, which is some of the considerations that you need to go through when you're designing or considering a new engine build. And for those who have been following us for a while, this should come as no surprise. Obviously we had a fairly catastrophic meltdown with one of our race engines a while back, and we're getting the car ready for our upcoming race season. Obviously, when we're rebuilding the engine, we're looking to add as much more power as we can while maintaining, well, hopefully improving our reliability. We'd like to not have it fall to pieces again. Now, this is something that I know a lot of people get into a situation where, particularly they're building a car for a race series. There's some rules around that race series, and it's quite frustrating when you go and build a combination and find out that the combination actually is either illegal for your race series. That's obviously a worst case scenario, or maybe you haven't really exploited the available rules to your favor, and you end up with a combination that's legal but maybe not particularly cost effective, or worse still, just completely not competitive. So again, during the webinar, which we'll get into next, we're going to have a look at what you need to be considering, and we're basically going to go through a bit of a brain dump of the thought process we're going through with our unused ZFE, or our 3U ZFE, I should say, rebuild. Part of that, and the next step we're going to get into, is the update that we're looking at for our dry sump system. So again, I've talked about this a little bit. I even posted on this on our Instagram, and of course, as soon as you do that, something's going to come up and bite you and make you look stupid. No exception here. However, we've got this work of art dry sump system here. I'll just quickly pick this up and sort of show you what it is. So this is a Dailey Engineering dry sump system that was actually designed for Toyota Racing Development TRD over in the US for their Grand Am engine, which is based pretty well on the 3U ZFE engine block. There's 6 of these TRD dry sump systems over here in New Zealand, because 6 of these TRD Grand Am engines were purchased by a New Zealand NZV8 touring car team to run in their cars. Unfortunately for them, and what we thought was hopefully a benefit for us, was that these sumps didn't fit, because the orientation or location of the dry sump pump ended up with it essentially fouling on the steering rack. It's just something that they couldn't move. So they actually had Dailey Engineering make a new revised system to suit putting the pump on the other side. I just want to go through a couple of the aspects of this dry sump system. So first of all, actually, before we go to our overhead camera, I'll just turn this around, and probably one of the often overlooked advantages with the dry sump system is just how much ground clearance it can give you. So this sump, the entire thickness of this sump is only around about 25 millimeters or 1 inch. So it's a very low profile, and I think I made a measurement of our existing sump, and it's somewhere in the region of about 4 inches or 100 millimeters. So that's a massive difference, and particularly if you're building a car where you've got the ability to relocate the engine in the engine bay. Being able to drop the engine down that far is a massive advantage. For us, it's not quite so significant. The reason being that we're kind of limited on what we can do with the engine location, given the headers. There's not a lot of room in the Toyota 86 engine bay to run the headers. The other thing is that the gearbox that we're running, the input shaft runs into the center of the gearbox. So basically, when we lower the engine, the bottom of the gearbox becomes the next lowest part of the car. So again, a bit of a limitation. That wasn't really why we were going for it, though. Let's have a quick look under our overhead camera. I'll show you a couple of the features here. So first of all, one of the really nice features, this is something I always like with proper motorsport equipment like this, is the fact that you can see the rails where it bolts to the sump have been O-ringed. And this isn't such a consideration for a daily driven car, but particularly with race engines, they generally are getting stripped reasonably frequently, and it can be quite time consuming to both apply silicon sealant or 3-bond sealant to the sump rails, as well as remove it and clean everything up before the sump goes back on. So the O-ring ensures a nice seal. There's no need to run silicon there or any kind of sealant. Makes it really quick and easy to remove and install the sump. The other aspect here, which is really nice, if I just move this across here, is that this has an integrated mount for the dry sump pump. The pump itself is actually here. I'll show you this in a bit more detail. That sits just like that. So this is nice because there's no need to go and machine up custom mounts. The other part though that's probably more important is that it does integrate the scavenge stages. In this case we can see we've got 4 scavenge stages directly into the sump. So basically each one of these stages draws from one of the compartments. This isn't completely sealed, I should mention as well. A lot of dry sump systems will actually seal the individual compartments to the engine block. That's not how this works. We talked to Bill Dailey back at PRI last year, and he actually found he's done some back-to-back testing with sealing each of the compartments, and actually found some negative side effects from that. So his preference is to keep them open. So these ribs here, probably I'm guessing as much as anything, are to provide some rigidity to the whole system. So anyway, we've got those 4 stages drawing straight into the side of the sump here, and then we've got the dry sump pump itself. So that's this little guy here. And it's a 5-stage pump. It's called a 5-stage pump. There's 4 scavenge stages, as I've already mentioned, and 1 pressure stage. So the scavenge stages are designed to extract the oil and basically all of the blow-by gases from the engine crankcase and evacuate those back to the dry sump tank, which is going to be mounted in the rear of the car in our application. The pressure stage is then designed to draw that oil forward from the dry sump reservoir, pump it through the oil filter, the oil coolers, etc., and then pump it through the engine. And when this is all set up properly, the aim basically is to ensure that there's a nice reliable supply of high pressure oil to all of those vital components. Another nice feature with the Dailey Engineering pump is this is optional from what I understand. This actually runs an oil air separator on the back of the pump, and the idea behind this is it removes a lot of the frothing from the oil. Basically when you're extracting the oil and air from the crankcase using the scavenge stage, you end up with this frothy mess of oil, and it's all heavily aerated. The dry sump tank is designed to help remove that aeration from the oil, but still there's a chance you're going to get some aeration still in the oil. So this gets rid of that straight away. It separates the oil and the air out. Alright, so great in theory so far, and I'll just mention here that while obviously the key aspect with a dry sump system is the improved lubrication, basically regardless of the lateral or longitudinal G-forces that the car is experiencing out on the racetrack, we're always guaranteed a nice steady supply of oil. So that's the first part, is the engine reliability. But another aspect that is easy to overlook is that when the dry sump system is designed properly, it actually can give some benefits in terms of power as well. And there are a few ways that it does this. First of all, by evacuating or scavenging the blow-by gases and oil out of the crankcase, it reduces the windage losses inside of the crankcase, which is basically the losses that are encountered when the crankshaft has to actually rotate through an oil mist in the sump. So getting rid of the oil mist in the sump can help reduce the windage loss and show a small improvement in power in that respect. The other advantage though is if we can draw a vacuum in the sump, and there's some limitations around what we can and can't do with that, but basically if we can create a low pressure area in the sump, this also gives us the ability to run a low tension ring pack. And the idea behind the low tension ring pack is it reduces the frictional losses from the engine rotating, so we see a little bit of power freed up. So it doesn't necessarily, let's say, make us more power in that respect, but we get less frictional losses, so we're just freeing up some of the power that would otherwise be wasted. Okay, so that's all good in theory. Unfortunately, it's not really working out quite so nicely for us when we got a chance to test fit this. So let's jump across to my laptop screen and we'll see what we're dealing with here. And you can see straight away we've got this rather awkward gap at the front of the sump. So I'm not too sure that filling this up with JB Weld or something similar is going to be a suitable solution. The reason that we've got this problem is that obviously these were designed for Toyota racing development, and because they are now a dry sump engine, this part of the front cover here that we can see, this contains the factory oil pump. So obviously that's not necessary anymore. So TRD, in their infinite wisdom, redesigned that front cover and made it much narrower. narrower. So first of all, we're not going to be able to use that for this reason. We do actually have the ability to get hold of one of the TRD front covers from the same source that we got the sump, but there are some other issues that we do need to consider as well. And this is probably the main one, and we knew that this was going to be a consideration. We basically got the sump down here so that we could check it all out and see how it was going to work out. So what we can see, first of all, running straight through where the dry sump pump needs to go is one of the runners for our exhaust manifold or header, and right here we've also got our engine mount. So none of this is impossible. We are already considering rebuilding the exhaust manifolds because they are actually a little bit small in terms of the primary runner diameter for the engine specification that we're considering going to. Actually, they're too small for what we were running. So that's one consideration. It's easy to say we'll make a new set of headers, but the reality is that it is an incredibly tight installation. So we don't have a lot of flexibility and a lot of freedom with where that manifold could run. So we could get into a situation where we can't actually really improve the clearance to the dry sump pump anyway. And then the other thing is the two AN fittings for the air oil separator come off the back. They're obviously going to want to run directly through the engine mount. So at this point, we're probably going to admit defeat and say it's all getting a little bit too hard. And the other issue with this was, I don't think I've got a good photo of it, but because the TRD engines ran a billet crankshaft, the crankshaft looks, from what we can tell, like it's actually made with a shorter snout. So we've just got a few other weirdness problems with the alignment of the dry sump drive pulley as well. So yeah, at this point it's probably in the too hard basket. Fortunately, we're not out of pocket over this. Our team that we dealt with at Richard's Team Motorsport were generous enough to just let us borrow one of these and the pump and see if they're going to work for us. So we're not in a situation where we're out of pocket, because let's be honest, these are a pretty pricey piece of gear. For anyone who is a Driftworks fan, you're probably going to be commenting on this in the comments anyway, so I'll just get in ahead. We know that Phil and the crew had basically exactly the same scenario, trying to fit a Dailey Engineering dry sump system onto their V10 engined E46 BMW M3. Unfortunately, from what I understand watching that video, Phil at Driftworks actually did have to buy that kit before he found out it didn't fit. Not actually too sure where he got to with that. We're at least in the fortunate situation that we already had a 3-stage dry sump system on the engine, so all's not lost. It could be much worse. We're probably just going to go back to that system. So moving on, we are also back into some action on our FD RX7, and for those who watched last week, I did talk a little bit about the clutch. So we'll just jump across and have a quick look at the clutch again on my laptop screen. So we went with an Agura Racing clutch twin plate system, and it's a bit of a sort of a catch-22 here. What we want is a clutch that's going to still be drivable, because this is predominantly a street car, and we also need something that's going to be able to handle ultimately in excess of 500 wheel horsepower once we have a build engine that we can really lean on hard. So I talked last week about the benefits of retaining a sprung center, which is what we can see here, take some of the shock load out of the drivetrain. I just want to mention here, because I didn't really jump into the clutch material in too much detail. So when we are choosing a clutch, the drivability of the clutch is what I was talking about last week, is quite important, particularly for a daily driven car. You can't overemphasize how important it is to have a clutch that drives really nicely, particularly if you get stuck in stop-start traffic. So in terms of drivability, the factory organic style clutch plates generally drive the nicest. That's why OE manufacturers use them. They're easy to slip, but they don't handle heat too well, and unfortunately in our instance, they're not going to be that great with the sort of power and torque that this engine's likely to make. So in this case, when we go to a twin plate clutch, there are limitations to what we can go with. We end up generally running a metal style clutch plate, which is what we can see here. This is the friction material, and some of these friction materials can be quite harsh. Even if you've got a sprung center, they can be a little bit difficult to drive, and generally what you find is once the clutch is actually bedded in, you're going to find that some of those metallic style clutch plates tend to create some shudder when you're taking the clutch up from a standing start. So we've got some experience with the ORC clutch, and they do tend to drive quite nicely. I just want to mention my own personal preference, but they are quite a lot more money generally, would be to go to a carbon clutch. The carbon material drives just like an organic clutch material, so very much like an OE clutch, very easy to drive, very easy to slip. The advantage with the carbon material as well is that they withstand heat incredibly well. So if you slip them off the start line, a drag race for example, you're not going to destroy the clutch really quickly. Now, when it comes to a clutch upgrade in an FD RX7, that actually has another little idiosyncrasy that goes along with it, which is the fact that we need to actually replace the existing flywheel, which has a counterweight built into it with an external rear counterweight. So again, we'll jump across to my laptop screen. Not a great shot, but that's basically what it looks like. So the rear of the eccentric shaft on the 13B, that has a taper on it and a single large diameter nut, and we need to convert to the rear counterweight, obviously, to get that counterweight in there, make sure the engine remains balanced, and also give us the stud pattern for bolting on the new flywheel. So Brandon's been into that. We've got everything installed there. That's the new counterweight in location. And one of the problems with the 13B as well is that they run this one single large diameter hex nut on the back there. So the counterweight is pulled onto a taper, it's keyed into place, and then we've just got this one single nut. Off the top of my head, I think the torque spec on this is somewhere around about 400 Newton meters as well, so a huge amount of torque. And I know that a lot of backyard DIY rotary engine builders kind of tend to get in there with a cold chisel hammer, removing it and installing that nut. Suffice to say that that is not the Mazda approved technique, but you are in a situation where you don't have a huge number of options for doing that. I'll just actually quickly see if I have got, here we go. Actually, let's jump back across to my laptop screen. Before I show you the solution to that, this is the factory flywheel, and you can see this section here, which is essentially the counterweight that we are replacing with that external counterweight that I just showed you. So the solution to doing up one of those nuts properly is a massive strong arm like this one here that Brandon's just about to start swinging on. Fortunately, we managed to borrow one of these from a race team around the corner who use these for doing up their center lock wheel nuts, but yeah, don't get in there with a cold chisel and a hammer. And if you are going to be in that situation, understandably with that much torque going onto that rear nut, it's also essential that the flywheel is properly supported, so you need to use a proper flywheel stop to make sure that it's not going to rotate, and you don't obviously want to do any damage to the teeth on the flywheel while you're tightening that up. So at this stage we are getting pretty close to having the FD RX7 wrapped up. We've got a little bit more wiring being done on it. Brandon is going to be busy this week sorting out some plumbing for the fuel system, and hopefully in the next few weeks we might be in a position where we can get that up and running. So we're pretty excited about that, and pretty excited to get some more rotary course content out there as well. Right, I just want to quickly pop across to our Instagram for a moment, and this is an Instagram that I put up a week or so back, and it's something that I know a lot of people kind of have an understanding that the inlet trumpet length has a fairly significant effect on the power delivery of the engine, particularly where in the RPM range we're going to see peak power and peak torque. The idea here is that in general terms, all other things being equal, a shorter inlet trumpet will favour high RPM performance, a longer runner favours low RPM performance. There's quite a lot of science that goes into getting the right runner length to take a sort of advantage of a ram effect of getting more air into the cylinder, improving the volumetric efficiency. So most people kind of get that, But it's interesting when we look at the likes of sport bikes, and in this case here, this Synergy V8, which is based around a pair of Kawasaki, I think ZX12R cylinder heads, that we see unequal length inlet trumpets, and this causes a little bit of confusion. Now, this is actually done purposely by sport bike manufacturers, in this case by Synergy, for two reasons. With the Synergy here, one of the advantages is because there is a tight space to fit this engine under the factory bonnet. There is a bit of an angle here from front to back, so the front of the engine, the front of the inlet trumpets, is lower than the back, giving a bit more space to the bonnet. That's the lesser consideration, though. The other aspect is by running 4 cylinders with shorter runners and 4 with longer runners, what it tends to do is you'll find that the runners that are long, obviously where they get peak volumetric efficiency or peak airflow into the cylinder, will be at a slightly different RPM than the other ones. So this kind of tends to even out the torque delivery, and it will give maybe a sacrifice of peak torque and peak power, but it can actually give a better drivability to the engine. Particularly, a lot of these sport bike engines are very peaky, so the actual peak power is probably less significant than making the engine a little bit easier to ride, or in this case in a car, a little bit easier to drive. So this brings about the next obvious question, in that if we've got different cylinder fills on different cylinders, is this going to affect our air fuel ratio and our optimal ignition timing? And of course the answer to that is yes. The ultimate way of tuning an engine like this, understandably, would be with individual cylinder lambda sensors, so that we can actually trim the cylinders with the short runners and the long runners to make sure that the fueling is consistent right through the rev range. Unfortunately, we're not always in a situation where we can do that. Today we have also just released our latest video. So this is one that we shot when we were at PRI last year. So this is an interview with Eric from Mahle Motorsport in the US, talking about the different piston coatings that are available, the pros and cons of the different coatings, and particularly if you have ever looked at the list of available coatings from different piston manufacturers, it can be a little bit confusing, a little bit daunting, knowing exactly which ones to choose, what they all do, and the pros and cons of each. In particular, I often hear people think that using a ceramic coating on the crown of the piston is kind of a foolproof solution, and it gives us a lot more headroom in our tune. We're not going to end up melting or damaging the piston. That's unfortunately a little bit optimistic and not quite accurate. So if you're interested in learning a little bit more about the different coatings, what they do, and which ones are suitable for your application, head over to our YouTube channel. Make sure you watch that video. If you enjoy it, give it a thumbs up, and if you've got questions, please feel free to ask. Which is a nice segue into the next section, which is our continued giveaway with Mahle Motorsport. They are giving away a set of their shelf stock pistons. I've got one of their pistons right here. This one happens to be for an LS build, but basically, as with the majority of piston manufacturers, they produce pistons for basically the widest range of popular Japanese and domestic engines out there. So if you are at a point where you're considering a build on your engine, then this is going to be perfect for you. You'll get a set of those pistons shipped to anywhere in the world, and you'll also get a suite of engine building courses from us that will let you know exactly what to do with your new pistons from Mahle Motorsports. I'll get the team to drop a link into the chat that you can follow to get your name into that draw, and I don't think that draw's got too long left to go, so you will have to move quickly. And we are also simultaneously running a giveaway for our ETS Fab project, so let's just head across to that. So our ETS Fab project, this is with Nigel Petrie from Engineer to Slide. Currently running ETS Fab as an online fabrication school, and we've partnered with Earnest Clothing as well, which is a supplier manufacturer of high quality fabrication workwear. So what you'll get with this package is a Earnest Fabrication Squire workshop apron, hardened overalls, you'll get a tungsten TIG MIG gloves, you'll get safety glasses and an Earnest hat, plus you'll get VIP membership to ETS Motorsport Fabrication School courses. courses. As you can see here, there are still 8 days left for that giveaway to run. So you've got time to get in the draw, and you'll see that there are also a range of other little activities here that you can click off, and each time you do one of those, it's going to give you more entries into the draw. So again, I'll get the team to drop a link into the chat that you can follow to get your name into that draw. All right, thanks for watching there, and give me a few moments. We'll get started with today's webinar.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.